Hey y'all, what's up? All right, so here's the next video. So for today, it was going to be in the review packet as well as 6.4 and 6.5. Okay, all right, this one's going to be a tricky one because you've got to actually work each of them out, but we're going to make it. Here we go. All right, starting with number 14, going over 6.4, that was perfect squares and exponents. 14, which of the following is true? Okay, so what we got to remember is if I'm just going to write out 3 squared, 3 is the base, 2 is the exponent. Okay, I read that as 3 squared, or I can also read that as 3 to the second power. Now, what this does not mean is that is not 3 times 2. The base is the number I'm going to multiply. The exponent is going to be the amount of times I multiply it. Okay? The number I'm going to multiply, the number of times I'm going to multiply it. Okay? So 3 squared, or 3 to the second power, is 3 times 3, and that is equal to 9. Okay? All right, so let's see what we got. So A, 4 to the third power, so that's just 4 times 4 times 4. 4 times 4 times 4, that is not 4 times 3, so it is not equal to 12. Same thing here. That is not 3 times 4. That is 3 times 4 times. So 3 times 3 times 3 times 3. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. 4 to the third power. 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is equal to 64. So that one does work out. 3 to the fourth power, so 3 times 3 times 3 times 3. All they did is just group those two together, make that 9, but they left it out over here. So that should be 81. So I know that one was wrong. So C is my correct answer. 15. Which of the following is not a perfect square? Okay, so what we need to remember about perfect squares. Again, perfect squares is we're going to take a number and I'm going to multiply it times itself. So like 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. Okay, all the way through. Okay, so now we've got to figure out 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, so on and so forth. So what we need to figure out is which one is not a perfect square. So which of those can I not take a number and multiply by itself and make that a perfect square? Well, I know 16 is a perfect square because that's 4 times 4. Okay. I know 36 is a perfect square because that's 6 times 6. I know 81 is a perfect square because that's 9 times 9. So which means 50 is not a perfect square because I can't take a number and multiply it by itself to make it 50. Okay? All right. If you have questions, confused on the 6.4 exponents and perfect squares, stop the video, rewind, or hit me up in email, Instagram, Facebook, the works. Okay? All right. The last one we're going to look through is we're going to work through 6.5. Okay? So 6.5 is going to be dealing with fractions, and we're going to be dealing with decimals. Okay? All right. So 16. So this is where we're dealing with either we're going to multiply or we're going to divide. So 16, I'm going to have 2 2/3 times 3 1/2. Okay. Now, I can't multiply those until I make both these an improper fraction. Okay. So what we need to remember with improper fractions is I'm going to multiply 3 times 2, and then I'm going to add whatever I get plus 2. So 3 times 2 is 6. 6 plus 2 is 8. So 8/3 times, same thing here, 2 times 3 is 6. 6 plus 1 is 7. So 7/2. Now I can multiply it. Okay, again, to multiply, I just have to multiply straight across. 8 times 7 is 56. 3 times 2 is 6. Now, I can't leave that as an improper fraction. What we need to remember again is I read this as 56 divided by 6. 56 divided by 6. So 56 is going to go on the inside. 6 is going to go on the outside. So now I need to remember. So I'm going to divide, multiply, subtract, bring down. I can't divide 6 into 5. I can divide 6 into 56. Okay? Well, I know 9 times 6 is 54. 6 times 10 is 60, so that's too much. So I'm going to go 9 times. 9 times 6 is 54. 6 times minus 4 is 2. So my remainder is going to be my whole number. What I subtracted is now going to be my numerator. My outside is going to be my denominator. Okay. So I get 9 and 2, 6. Well, I can realize I can divide, make this fraction smaller. So I can divide both sides by 2. Divide by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. So I get 9 and 1/3. 9 and 1/3. 9 and 1/3. All right, 17. So I'm going to divide 6 and 1/3 divided by 3. So 6 and 1/3 divided by 3. Now, I'm going to go ahead and bring that division, and I'm going to make this a fraction by putting it over 1. Okay? Now, same thing I did with multiplying. I've got to make this an improper fraction. 3 times 6 is 18. 18 plus 1 is 19. So I end up with 19 over 3. To divide, I need to keep, change, flip. I'm going to keep this first fraction, change this division to multiplication, and I'm going to flip this fraction. I'm going to make it its opposite, where it's reciprocal. 3 over 1 is now 1/3. 19 times 1 is 19. 3 times 3 is 9. That's 19 divided by 9. 9 is going to go on the outside. 19 is going to go on the inside. 9 can't go into 1, but 9 can go into 19 2 times. 2 times 9 is 18. 19 minus 18 is 1. So I get 2 and 1/9. 2 and 1/9. 2 and 1/9. Okay? All right. So that was all with multiplying and dividing. All right. So now let's put it in some word problems. All right. So 18. So Chris played video games for 3 2/3 hours, and Jake played video games for 4 1/3 hours. Which statement is true? Okay. Now, here's what we need to notice first. Who played longer? Jake did. Okay. He played longer. So what we need to look for is go ahead and find the 2, narrow it down, and say that Jake played blank longer than Chris. Okay, so I know A is out, and I know C is out. Okay, so now I need to subtract it. Okay, so I'm going to take 4 1/3, subtract 3 2/3. I want to make these both improper fractions, so that's going to be 13/3. 3 times 3 is 9. 9 plus 2 is 11 thirds. Okay? So here's what I've just got to do. Since both of these are the same denominator, I can just subtract it. 13 minus 11 is 2. Okay? So he did 2/3 more hours than Krish. Okay? That's it. All right, 19. So Samir ran for 2 1/3 miles on Monday, 3 3/4 miles on Tuesday, and 2 1/4 mile on Wednesday. How many miles did he run in all? Okay, keywords. So what that's going to mean is I'm going to have to add all of these fractions together. Okay, so what I'm going to do is I'm going to put them in order from greatest to least. Okay, so 3 3/4, 2 1/4, or sorry, 2 1/3, and 2 1/4. Okay. Now, you can technically do this one multiple ways. Okay? You can do this one multiple ways. You can add them. You can do like I do when I first did it. I made all of these decimals. So 3.75, 2.333, 2.250. And you can add them that way. Or let's look at it this way. So I want to rewrite them again. 2 1/3, 2 1/4. Okay. Now, here's what I'm going to do. I'm going to first add these whole numbers. 3 plus 2 is 5. 5 plus 2 is 7. Now, here's what I want you to notice. What do I get when I add 3/4 and 1/4? That's a whole. So that's another whole. 8, and then I just got to bring down my 1/3. Okay? So let's look at it this way. 3, 10 plus 3 is 13. 10 plus 2 is 12, plus 1 is 13. 5, 6, 7, 8. So if I write that as a fraction, that's 8. 8's my whole number. And then what fraction would be 3,300 repeating? 1/3. Okay. So my answer would be A, 1/3. Okay. All right, so that's it for the fraction word problems. This is going to be a definite one that I would stop and rewind. Would definitely stop and rewind and go back over it if I was confused. Or I would definitely email me, message me in Classroom, hit me up on Facebook, Instagram, or find any other resource to help you. Okay. All right, and last one. Okay, now we're just dealing with decimals. Okay, we're just dealing with decimals. So first we have to read it. So 20. Lucy and Morgan are making necklaces. They buy 4 rolls of string that are each 22 1/4 feet long. If each necklace requires 2 8/10 feet of string, how many necklaces can they make? Okay, so here's a big key that you need to realize, that 4 rolls are 22 4/10 feet long. Okay, so what we're not doing is it's not going to divide this by how many it takes. Okay, we got to combine them all together. So I'm going to take 22 4/10 by 4. Okay, 4 times 4 is 16. Carry the 1. 4 times 2 is 8, plus 1 is 9. 4 times 2 is 8. One place, one place. So altogether, she has 89 6/10 feet of string. Now what we need to do is take how long this all together and now divide that by each necklace. Okay, so I'm going to take 2 8/10. That's what I want to divide by. Divide them into 89 6/10. Now, we cannot leave this decimal here. So I need to shift it to the right. So now I'm just left with 28. But I also need to shift it right over here. What I do over here, I have to do over here. So now that's 896. So now we're just going to divide 896 divided by 28. Well, first I need to figure out how many times can I go into 89. Can't go into 8. So let's say times 4, 2, 9, 10, 11. That's way too much. So let's try 3. 4. Here are the 2, 6, 7, 8. Okay, so 3 works. So we're going to go 3. 3 times 28 is 84. 5. 56. Well, if that's 84, let's try times 2. 6. I think we know where we're heading. 2 times 2 is 4, plus 1 is 5. 56. So 32 necklaces. So she can make 32 necklaces. Okay? All right. I totally forgot about question 21. Okay. So 21, and this is the last one, and we will be finished. So the cost of a large pizza is $7.99. You have a coupon for $1 off of each pizza. You buy 5 large pizzas. How much will your total cost be? Now, you can technically do this one 2 different ways. And either way is up to you. What I would do first is go ahead and subtract the coupon from $7.99. Okay, so $7.99 minus $1.50. Okay, so 9, 4, 6. Okay, so each pizza is now actually going to cost $6.49. Now I'm going to take $6.49 times 5, because we're buying 5. 45, 24, 30, 32. So to get all 5 is $32.45. Now, you're saying, well, you said you can do this another way. Yeah, you can. Okay. What you could have done is go ahead and multiplied $7.99 times 5, how much it would have been before the coupon, taking $1.50 times 5, and then subtracted the 2. But what I would have done is just go ahead and take the coupon off and then multiply it times 5. So $32.45. Okay? All right, folks. So that's it for today. Okay? So we'll be back tomorrow for the last little bit of the packet, and then we will be done. Reminder, packets, if you have the packet, it is due by Monday. If you're online, it is due by Friday. Okay? Online is due by Friday. Packet is due by Monday. Okay? All right. I'm out.